This lesson is for section 1.5, which is solving equations and inequalities by graphing. For the first day, we looked at solving equations specifically. So I'm going to look at example 1, A and B, to kind of discuss the process. So when we are given an equation and we want to use a graph to solve, we are looking at either side of the equation and identifying what that graph would look like. So for this first one, the left side is a linear function, negative 3x plus 20. And so what we want to do is graph that line. So notice that this line has a y-intercept of 20 and a slope of negative 3. And so that means that we're going to plot a point at 20 and then go down 3 and then to the right 1 to create a line with the slope. So I'm going to graph that in as much of the coordinate plane as I can. And so that is our line. For the left side of the equation, which is negative 3x plus 20, we graphed as y equals negative 3x plus 20. We're going to take the right-hand side and do the exact same thing. So we've got y equals 5. Remember that this is still a linear equation with a slope of 0. And so that means that this has a y-intercept of 5. So we're going to start on the y-axis of 5. And since it has a slope of 0, we're going to go up nothing over 1. So we're really just drawing a horizontal line through 5. And the question is asking us to find the point of intersection. So for this graph, we can see that the point of intersection is the point 5, 5. And so the answer to the question lies in that point. So remember that we were given an equation that was strictly in the variable x. We added the y's to create our graph. And so that means that the answer to this problem is just the x value. So the answer is x equals 5. So we think about that. We could go back and check that answer in the original equation. So if we do negative 3 times 5 plus 20, we're checking to see if that is equal to 5. So negative 3 times 5 is negative 15. Negative 15 plus 20 is 5. And so we know that that solution is true. So really, we could have started with that original equation and easily solved to get that value 5. But some equations are not as easy as that. And so if we look at example 1b, we have an absolute value equal to something that's linear. And so this process makes this problem a little bit better, because if I think about this equation as y equals the absolute value of x minus 4, remember that if we think about a, h, and k, that helps us graph an absolute value, or a quadratic for that matter. So a is the number in front of the absolute value symbol. Since there isn't a number, that means a is 1. H is the number that's being subtracted from x. And so that means h is positive 4 because it's x minus 4. So 4 is being subtracted. The other trick is whenever there's a number inside the parentheses, it's always the opposite sign when you identify that coordinate. And then k is the number that's being added on the outside. This technically has a plus 0. And so that means that k is 0. And so what these numbers tell us is that this absolute value function has a vertex at 4, 0, and a pattern of up 1 over 1. So A gives us that pattern. So we're going to plot a point 4 to 0, and then go up 1 over 1, up 1 over 1 in both directions. And so we're getting this shape for our absolute value. So that's the first half of our process, is identifying the graph of one side of the equation, and then now we have to graph the other side of the equation, and we're looking for the x values of those intersections. So our second one is 1/2 x plus 1, so we're going to make that y equals 1/2 times x plus 1. So this is a line, and I know that because x is to the first power, that has a y-intercept of 1 and a slope of 1/2. And so I'm going to plot my y-intercept at positive 1. My slope tells me to go up 1/1. So notice that it's crossing here. So I know that that's my first point of intersection, but if I continue my pattern, I can see that it's going to cross again here at 10. So our line looks like this. It intersects that absolute value function in 2 places. So we have our points of intersection at the points 2, 2, and at the point 10, 6. And so remember that because our original equation only had values for x is equal to 2 and 10 for this problem. And so again, we could plug those in if we wanted to check our values. So the absolute value of 2 minus 4 should be equal to 1/2 times 2 plus 1. So if we simplify each of these, that's the absolute value of -2. And then that is 1 plus 1. And so notice that both of these values equal 2. So that's good. Our answer 2 is good. If we do the same thing with 10, the absolute value of 10 minus 4 equals 1/2 of 10 plus 1. 10 minus 4 is 6. And then 1/2 of 10 is 5 plus 1. And so we can see that both of those values equal 6. So that's how we solve an equation by graphing. We graph each line individually, and then we find the x coordinates of their points of intersection, and that is the solution to the problem. We can check if we're worried about our answer.